Okay, guys, so we're officially entering the world of bivariate data. Probably more common than talking about individual variables is examining data with more than one variable. Definitely more common. Fortunately, the examination of several variables is actually much the same as what we did with individuals. So we plot our data, we look at our numerical summaries, we like to look for overall patterns and departures uh, in our distribution. And then finally, if we see something that looks like a regular overall pattern, like a normal model, we would want to use a simplified model to describe it. So most statistical studies examine data on more than one variable. Okay, in many of these cases, two variables play different roles. So that might be something like car weight. Does car weight help explain the amount of accidents that result in death? Does smoking influence life expectancy? In these relationships, the two variables play different roles. So accident death rate and life expectancy are the response variables of interest, where the car weight and the number of cigarettes smoked would be more of an explanatory variable. So a response variable measures an outcome of a study. An explanatory variable may help explain or influence changes in a response variable. Okay? A response variable can often be called dependent, where an explanatory is often called independent. So, you might you might see something where you're looking to see if a certain medication has an effect or has an effect on body temperature. Okay, so what you're going to do is you're going to give different amounts of certain medication to, let's say, like a lab rat, and you're looking to see if that causes a change in the body temperature. So the explanatory variable would be the amount of the medication that you give, where the response variable is going to be the change in the body temperature. So it's responding to the explanatory variable. Okay. So something to keep in mind too. Actually, we'll talk about that in a second. In many studies, the goal is to show that changes in one or more explanatory variables will actually cause changes in a response variable. So something like that would be, does medication change body temperature? So in that one, you're talking about medication would actually cause a change in body temperatures, okay? But there's other explanatory response relationships that don't involve direct causation, okay? So something like that might be, like there may be a relationship between an SAT math score and a critical reading score because they're closely related, but that doesn't mean that you can use the SAT math score to predict its critical score. So there's no direct causation there, although there may be some relationship that happens there. Okay, so Julie asked, can I predict a state's mean SAT score if I know its mean SAT critical reading score? So Jim wants to know how the mean SAT math and critical score reading scores this year in the 50 states are related to each other. For each student, identify explanatory variable and response variable if possible. So Julie is going to treat the mean SAT critical score as the explanatory variable and the mean SAT math score as the response variable. Jim is simply interested in exploring a relationship between the two variables. So for him, there wouldn't be a clear answer to what an explanatory or response variable would be. Okay. So we're getting our way into scatterplots here. Okay, so the most useful graph for displaying the relationship between two quantitative variables is a scatterplot. Okay, Scatterplot you guys have seen before, okay? It shows the relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, and the values of the other variable appear on the vertical axis. Each individual in the data appears as a point on the graph, okay? These are done no differently than you have ever done them before. So how to make a scatter plot. You're going to first decide which variables should go on each axis. You're then going, this is a helpful little hint. So the explanatory variable has to go on the x-axis, okay? So actually, maybe even before deciding which variable goes on each axis, you first have to decide which variable represents explanatory and which is the response, and then label it correctly. Then you're supposed to label and your scale your axis as you do with any graphical display, and then you're going to just plot the individual data values, and that's it. So let's go ahead and take a look, and you guys can work with me at the plotting those, scores, points per games, and games won for SEC football. Okay, so at the end of the 2011 college football season, the University of Alabama defeated Louisiana State University for the national championship. Interestingly, both of these teams were from the Southeast Conference, the SEC. Here are the average number of points scored per game and number of wins for each of the 12 teams in the SEC that season. Okay, so you guys have the numbers in front of you. Okay, and we have to make a scatter plot of the relationships between the points per games and wins. Okay, so the first thing that we're going to do is decide which variable should go on which axis. So before that, I'm going to identify what I'm going to think is the explanatory and the response, okay? I'm going to say that the explanatory variable is going to be points per game, okay? And I'm going to say that the response variable is going to be the number of wins, okay? So, so then I'm going to label and scale my axes, okay? So let's see, the team's points per game vary from 15.8 to 36.8, so I think it's pretty good that if we can start this at 15, and we'll make every tick mark worth 5. And then the team's wins vary from 2 to 13, so I think we could start at 0, and I think we could do every 2. Okay, and that's it. Now I'm just ready to start plotting each one, okay? So let's see, I got 34.8 for points per game for Alabama. So 34.8 just before my 35, and I have 12 wins, okay? So in about there, okay? Then I have 36.8 for Arkansas points and 11 wins. So 36.8 and 11 wins. Okay. Let's see, 25.7 to 8 for Auburn. Okay. Keep going, 25.5 and 7. Uh, 32 and 10. 15.8 and 5. 35.7. 13. Should maybe read a little higher. 16.1 and 2. 25.3 and 7. 30.1 and 11. 20.35 and 26.7 and 6. And that's making scatterplots. Okay. And of course from here, we now have to start to interpret our scatterplots. Okay, so we're going to use a lot of the same things that we've been doing in chapters, it wasn't 1 and 2, it's actually chapters 2 and 3. We're going to look for patterns and import departures from these patterns. Okay, so as in any graph that we've ever done, okay, well, with quantitative anyways, we're going to look for our overall pattern, striking departures, okay. You can describe an overall pattern of a scatterplot, a little bit different, of a scatterplot by the direction, the form, and strength of the relationship, okay? Each of these we'll talk more about. An important kind of departure is an outlier, much the same as with a single variable, an individual value that falls outside of the pattern of the relationship. Okay, so let's take a look at the SAC football, okay? This is obviously a computer-generated scatterplot, so it's a little bit cleaner than mine was, okay? Let's talk about the direction. So in general, it would appear that that teams that score more points per game have more wins than teams that score fewer points per game have fewer wins, okay? We can say that there is a positive association between the points per game and the wins. Okay, now the form. So there seems to be a linear pattern in the graph. That is, the overall pattern follows a straight line here. Okay. And the strength. So because the points do not vary much, okay, it's okay to vary a little, but they don't really vary too much. They don't deviate too much from your linear pattern. The relationship, we can say then, would be very strong or fairly strong. Okay, there don't appear to be any values that are outside of your linear patterns, so I'm pretty sure it's safe to say that there are no outliers. Okay, so I'm going to call this quits on this video. And we'll talk more about the direction in the next one.